Welcome to G Fun Facts Online, where we dive deep into the fascinating science shaping our world. Today, we are exploring a staggering reality hidden behind a global ritual of indulgence. When you snap off a square of your favorite dark chocolate, you probably are not thinking about the millions of tons of biological waste generated by the chocolate industry every single year. But here is the crazy part. For every cocoa bean harvested, fermented, and roasted, up to 80% of the cacao fruit is left behind. We are talking about cocoa pod husks, bean shells, and sweet mucilage that have historically been viewed as useless agricultural byproducts, left to rot in fields or piled into compost heaps. But what if this massive mountain of waste is actually a mountain of unmined gold? Today we are looking at a revolutionary green technology called ultrasonic biomass upcycling. This is a brilliant engineering leap that entirely reframes how we handle agricultural waste by using high-power sound waves to literally crack open the cellular fortresses of cocoa waste. The goal is to extract incredibly potent, high-value antioxidants, solving a massive environmental issue while creating premium bioactive compounds for pharmaceuticals, cosmetics, and functional foods. To really understand the magnitude of this breakthrough, we have to look at the anatomy of the Theobroma cacao tree's fruit. The cocoa beans we use for chocolate make up merely 20 to 25% of the total weight of the cocoa pod. The remaining 75 to 80% consists of the thick outer shell known as the cocoa pod husk, the thin papery layer encasing the bean called the cocoa bean shell, and the pulp. Historically, leaving this residual biomass to decompose in fields was a massive nuisance. Rotting cocoa husks breed black pod rot and other fungal diseases that threaten future harvests, turning waste disposal into an economic burden for farmers. However, modern biochemical profiling has completely flipped the script. We now know that these discarded components are astonishingly rich in phytochemicals. Cocoa pod husks and bean shells contain massive reserves of polyphenols, flavonoids like catechins, methylxanthines including theobromine and caffeine, clovamide, and valuable dietary fibers like pectin. Polyphenols are especially critical here. They are potent antioxidants, highly effective at neutralizing free radicals, which are those unstable molecules that cause cellular damage, oxidative stress, and contribute to aging and chronic diseases. In fact, plant-derived polyphenols can be up to 100 times more effective than vitamin C at neutralizing these harmful molecules. The big challenge has never been finding these antioxidants, but rather extracting them efficiently, profitably, and sustainably. For decades, extracting these bioactive compounds relied on legacy methods like maceration or soxhlet extraction, which have severe drawbacks. They require immense volumes of harsh, often toxic petrochemical solvents like methanol or hexane. They are also notoriously slow, sometimes taking days to yield results. Even worse, they rely on prolonged exposure to high heat to separate the compounds from the biomass matrix. Because many antioxidants are highly heat-sensitive, boiling them for hours degrades their molecular structure, drastically reducing the potency of the final extract. This is where ultrasound-assisted extraction, or UAE, changes everything. Imagine a microscopic demolition crew operating at the speed of sound. UAE utilizes high-frequency sound waves, typically ranging from 20 to 100 kilohertz, just above human hearing. These waves are transmitted directly into a liquid solvent containing milled cocoa waste. As these intense ultrasonic waves propagate through the liquid, they create alternating cycles of high-pressure compression and low-pressure rarefaction. During the low-pressure cycle, the waves create microscopic vacuum bubbles in the liquid. These bubbles grow over several acoustic cycles until they reach a critical mass where they can no longer absorb energy. At this point, during a high-pressure cycle, the bubbles violently implode. This phenomenon is known as acoustic cavitation. The collapse of these cavitation bubbles is dramatic. On a microscopic scale, the implosion generates extreme, localized hotspots, with temperatures reaching thousands of degrees Celsius, accompanied by shock waves and high-velocity liquid jets traveling at hundreds of kilometers per hour. When these microjets strike the suspended cocoa biomass, a highly destructive yet precisely controlled sequence occurs. First, erosion and fragmentation physically break down the tough, lignocellulosic structure of the cocoa waste, drastically increasing the surface area. Next comes sonoporation. where the acoustic energy punches microscopic holes into the rigid plant cell walls, compromising the fortress that holds the target antioxidants. Finally, enhanced mass transfer uses intense, localized turbulence to force the solvent deep into the biological material, washing out the intracellular compounds, like polyphenols and theobromine, dragging them into the liquid matrix at unprecedented speeds. What used to take 24 hours in a heated maceration vat now takes just minutes at vastly lower temperatures, preserving the delicate antioxidants and radically reducing energy consumption. Perhaps the most exciting application of this technology recently emerged from the State University of Campinas in Brazil, where researchers devised a way to extract cocoa antioxidants without using any synthetic chemical solvents. Instead of ethanol or acetone, they used native Brazilian stingless bee honey. Honey is naturally slightly acidic and has its own water content, making it a miraculous natural solvent. The researchers placed milled cocoa bean shells directly into the honey and submerged an ultrasonic titanium probe into the mixture. As the ultrasound waves pulsed through the honey, acoustic cavitation went to work, bursting microbubbles against the cocoa shells and releasing a flood of caffeine, theobromine, and antioxidant-rich phenolic compounds directly into the honey. The result is a functional, naturally sweet chocolate honey with a rich chocolate taste derived entirely from upcycled waste, requiring no added sugars or artificial flavorings. It is a nutritional powerhouse, loaded with cardiovascular supporting stimulants and anti-inflammatory compounds. Interestingly, this process also acts as a cold pasteurization technique. Native stingless bee honey usually has high water content and ferments easily, but the intense physical forces of ultrasonic cavitation disrupt the cell walls of native bacteria and yeast, naturally extending the shelf life of the honey without boiling away its beneficial enzymes. While edible solvents like honey are perfect for direct-to-consumer foods, industrial upcycling for cosmetics and pharmaceuticals requires larger-scale systems. This is where ultrasound is paired with natural deep eutectic solvents, or NADEs. NADEs are a new generation of green solvents made from naturally occurring, biodegradable compounds like plant sugars and amino acids. A recent study evaluating cocoa pod husks in southern Vietnam paired UAE with NADEs at a mild 50 degrees Celsius for 40 minutes, maximizing the extraction of flavonoids and FLAVAN, threols, without highly toxic petrochemicals. The economics are incredibly compelling. Research shows that optimizing sonication time to just 60 minutes using distilled water achieved massive phenolic yields. Factoring in the low cost of waste material, reduced energy usage, and the high market value of antioxidant extracts, the ultrasonic process generated an estimated profit margin of over $34 per kilogram of processed extract. Because ultrasonic extraction equipment features linear scalability, the exact same acoustic cavitation principles used in a laboratory beaker can be perfectly replicated in 1,000-liter commercial flow-through reactors. This creates an incredibly lucrative secondary revenue stream for cocoa producers. To ensure these technologies are genuinely sustainable and avoid corporate greenwashing, scientists use a new evaluation framework called Path to Green. This metric assesses 12 principles of green extraction, from energy consumption and transport to solvent toxicity and biodiversity preservation. Ultrasound-assisted extraction performs exceptionally well under Path to Green because it utilizes renewable agricultural byproducts, preventing them from rotting and emitting greenhouse gases like methane, relies on low heat, drastically reduces processing time, and functions perfectly with green or edible solvents. It perfectly closes the loop of the circular economy. The implications extend far beyond cocoa. If ultrasound can successfully strip precious antioxidants from the tough fibers of a discarded cocoa pod, it can be applied to almost any agricultural byproduct, from grape pomace in the wine industry to coffee, silver skins, and olive mill waste. For the cocoa industry, the extracts generated through ultrasound are already entering high-end applications. The polyphenols from cocoa bean shells are powerful anti-aging ingredients for cosmetics, protecting human skin against UV-induced oxidative stress and promoting collagen retention. Purified theobromine and clovamide extracts are packaged as nutraceutical dietary supplements to support cardiovascular health and provide jitter-free energy. Even the residual pectin from cocoa husks can be spun into biodegradable, edible bioplastics used for active food packaging to prevent spoilage. The journey of the cocoa bean has always been one of transformation, from a bitter raw seed to the globally beloved luxury of chocolate. Now, through the ingenuity of ultrasonic engineering and green chemistry, we are extending that transformation to the 80% of the plant we used to throw away. Ultrasonic biomass upcycling proves that waste is merely a resource in the wrong place, waiting for the right technology to unlock it. By harnessing the invisible, violent power of sound waves, we are not just cleaning up agricultural pollution, we are engineering potent antioxidants, creating novel superfoods, and forging a deeply sustainable circular economy. The next time you enjoy a piece of chocolate, consider the incredible unseen potential left behind in the field, and the sound waves silently turning that waste into the medicine, cosmetics, and superfoods of tomorrow. Thank you for joining us today on G Fun Facts Online.